Good morning, friends. Uh, Today we are going to discuss on the topic of EMF, terminal voltage, and internal resistance. See here, uh, I have taken one battery cell. So I have connected three bulbs parallelly to this battery cell. So when I connect up more bulbs parallelly, then what will happen is the more current is drawn from this battery. So because of that, the brightness of the bulb will goes on reducing. So this brightness of the bulb goes on reducing. So battery starts draining here. So when I connect from this, what I can say that when I connect more bulbs parallel to this battery cell, what will happen is the brightness of the bulb is reduces. The brightness of the bulb is reduces. This is because a more circuit connection is there, then more current is drawn from the battery cell. So the more current is drawing means the brightness is reducing because the same potential drop is applied across all the three bulbs. So when I remove these bulbs, so this is my battery cell. So one end is a positive and another one is negative end. So when I remove these bulbs, so if I take only one bulb here, so if I take only one bulb here, then what will happen is the bulb will glows very higher. So this brightness of the bulb increases. Brightness of the bulb increases because the less current is drawn from the circuit here, and with the help of these concept, what we can study is we need to find out what is the meaning of the EMF and what is the meaning of terminal voltage and internal resistance. See here, in almost all the battery cells, they have mentioned like this, like 9 volt EMF. See, this EMF stands electromotive force. The actually here, this is not measuring any kind of force. This is not measuring any kind of force here, EMF. See what it is representing is it is representing a energy. See, this EMF is representing energy. Means if it is mentioning it as a 9 volt, this means this is producing 9 joule of coulomb of 9 joule per coulomb of charge. That much of energy it is producing. See, we all know that electrons flows inside the circuit, but for our convention our convention what we take is a positive charge is moving inside. So actually the electrons will move inside, but for our convention what we study is in this circuit, in all the circuit, positive charges moving in this circuit. So now we have taken a battery and I have connected one bulb to this battery cell, so that is connection is parallelly. See, when the positive charge starts to moving in this circuit, this 9 joule per coulomb, 9 joule of energy is transferring to this positive charge. So because of that, the positive charges will move here. So these positive charges will move here. So it will not experience any difficulty here. When this positive charge comes at this end, even there is a positive charge and there is a negative charge. So here there is a attraction between the positive and negative charge. So it easily pushes here and these positive charges will come here. And now the real game is happening here. See, now what is happening? There are two positive charges and these positive charges need to cross this positive terminal of the cell. So these positive charges need to cross this positive terminal of the cell. Then this 9 joule of coulomb of energy plays into the role and it gives the extra energy to this positive charge to pass here to cross this positive terminal of the battery. So these positive charges will come here. So likewise, this 9 joule per coulomb of charge is utilizing in order to make the movement of positive charges inside the circuit. So the my question is whether this 9 joule per coulomb of charge is transferred across this bulb. So think about it for a while. See, we know that these battery cells have some chemicals inside it. So they have some chemicals. So whenever the positive charges moving inside this battery cell, so there is a chemical. So because of that, what is happening, these positive charges will make a contact with chemicals. So these positive charges make a contact with chemicals. Then what is happening is, because of the frictional force develops, so large amount of heat is liberated here. So large amount of heat is produced here. So once this large amount of heat is produced, means some amount of energy is losing, large amount of heat is produced because of the contact between positive charges and the chemicals present in the battery. So some of the energy is lost. So for example, if I have taken 2 joule per coulomb of charge, energy is lost here. So 2 joule per coulomb of charge energy is lost here. So now the 9 joule per coulomb of a charge is already present in the battery cell, and because of the heat, 2 joule per coulomb of charge is we are losing. So the battery or the shell, across this one we get a energy. So this is a battery. So across this, the voltage drop. So how to calculate this one voltage drop? Means the battery is supplying at 9 joule per coulomb of charge, and because of the heat loss, this is getting around 7 joule per coulomb of charge. Do you agree? See, it is supplying a 9 joule per coulomb of charge and 2 joule is lost because of the heat. So the voltage drop across the bulb we are getting is 7 joule per coulomb of charge. So this is, we are mentioning it as, this is we are calling it as the terminal voltage. So the terminal voltage, I can call it as potential difference, potential difference across the two electrodes, across the two electrodes when a circuit is closed, when a circuit is closed. So once we circuit is closed, then only the current is drawn from the battery. So now what is EMF? So this EMF is nothing but I can write that the maximum potential difference across the electrodes when the circuit is open. So always EMF is greater than a terminal voltage. And now comes the internal resistance. See, uh, this battery is always having a some resistance. See, we we have discussed that when a positive charges is comes near to the positive terminal of the battery, then there is a repulsion. So to overcome this, we are supplying the 9 joule per coulomb of energy. So whatever this repulsion and whatever the energy loss because of the heat, I can call it as the internal resistance of the cell. So because of that, we have getting the because of the internal resistance, we are getting here 7 joule per coulomb of charge. And here, how to put all these in a mathematical form. Sorry. See, we know this VT. VT is nothing but a terminal voltage. So from this, what I can write 9 joule per coulomb. So this is present in the battery. So that we are calling it as a EMF of the battery. And 2 joule per coulomb of charge is nothing but a heat loss. So this heat loss is because of internal resistance of the cell. So this is internal resistance of the cell, and this internal resistance is nothing but voltage drop across this battery. This internal resistance is nothing but voltage drop across the battery cell. So if there is a battery like this, and there must be some internal resistance here. So this is a voltage drop across the battery cell, and from the Ohm's law, what we can do is voltage drop, we can directly write it as IR. I is a current flowing through this battery cell, and R is the internal resistance. So this VT is equal to EI minus R. And now, what is a current flowing through this circuit? Suppose if I have taken uh, some register over here, if I have taken one extra register, and later I am connecting some bulb over here, so there is a battery cell here. So this resistor is R, so this is positive and this is negative. So this is producing 9 joule per coulomb of energy. So if I want to calculate a current flowing through this circuit. So if I want to calculate current flowing through this circuit, see, this I depends upon this resistor value which is connected series to the bulb, and then there is a internal resistance present in the battery cell. So from that, what I can write is I equal to R plus R. R is capital R is external resistance that we are connected, and small r is internal resistance. So the magnitude of the current is this magnitude of current So we know that I is equal to V by R. So instead of V, what I will take is EMF value. So that is R plus R. So this is the magnitude of the current. I hope all you have understood what is internal resistance and what is the EMF of the battery and terminal voltage. Thank you.